Hello, can you hear me, Shailesh?
Yes, yes.
Let Let's 5 to 10 minutes.
Okay, okay.
Hello, can you hear me properly?
Yes, sir. Good evening, sir. I am able to hear you.
Can you introduce yourself? Hello, where are you from? And your university, like
Yes, sir. Sir, I am Anmol Kumar, currently pursuing my Material Science and Engineering Masters from CPET IPT Bhubaneswar.
IIT Bhubaneswar. Hello, okay. And Shailesh,
Hello,
please introduce yourself.
I am Shailesh Kumar Shah. Currently, I am doing PhD from IIT Kanpur in Sustainable Energy Engineering Department.
Hello, ma'am. Please introduce yourself. So, let me introduce myself. I am a TA on nature and properties of materials and introductory course instructor, Professor Ashish Garg. So, my TA detail is here. You can see. My email ID. MRF scholar at IIT under the supervision of Professor K.L. Yadav, supervisor Professor Ashish Garg. We will discuss the numerical and the fundamental questions on introductory course on materials and properties. Commonly, three tools are there. Let's wait 5 minutes. In this course, we will discuss what is the material like that semiconductor, metal, ceramics, etc. etc. Further, unit cells of the material heads form. What is this smallest unit? Which is called unit cell. So how many systems are there? We will discuss that in this course. So there is a question regarding the first week lectures. Which of the following property of metal are superior to those of ceramics? First option hardness, second option ductility, toughness, yield strength. Can you answer the question?
Utility.
And others, please answer.
Ductility and toughness, sir. Both of them can be.
Toughness also. So your interaction will be count for in the course, and attendance also counts. We will provide these details to the MRF coordinator. We will give the marks to you. So please attend the class properly and discuss with me. So answer is ductility and toughness. First, so sir has already taught in class. Metal has high toughness, gassy high stiffness, ductility, and wide range of strength depending on the composite and processing, thermal and electrical conductivity, reactive corrosion resistance. So metal is and properties. Secondly, professor also polymers, elastomers. Please read these things if you give the exam and wants to understand what is the material. So please remember these properties. Hybrid hybrid mixer of compounds metal magnet. So expensive, difficult to shape and join property depending on the composition combination of the materials. Polymers you also know light and easy shape, high strength per unit weight, and lack stiffness, property high sensitivity temperature, and elastomers lack stiffness, low energy, less than the metals, able to retain initial shape after being stretched, relative strength and toughness, and ceramic, hard, erosion stiff high compression resistance, good high temperature strength, good corrosion resistance, brittle. So ceramic has brittle, glass has hard corrosion resistance, plastic insulation, insulating, transparent or brittle. So remember these properties of the materials like ceramics, glass, polymers, elastomers, metals, or mixture of hybrids. Okay, so start question might be asking exam. Let's discuss second question. The most electronegative element in the periodic table. If you know, please answer the question.
So fluorine 4.0, I think.
My slide is stick or
No, sir, slide is not visible.
This
stick now.
now it is
Now it is coming. Okay. So are you able to see my question checking?
yes, yes.
So please the answer the question.
I think chlorine.
So answer is fluorine. Why is fluorine? Answer has told is electronegative by this is minus 0.072 plus 4.0 strongly electronegative if pi has this value strongly positive then minus 0.07. So lithium has 1.0, sodium 0.9, potassium 0.8. These are the values. So when we go in periodic table from left to right, change this direction, then electronegativity tends to increase. So fluorine here as the highest when we move this side. So this is the electrophilic tendency to donate electron to bonding. This is accept. This will accept. Okay. So then third question. The energy of the primary bond is the range of. You know the two type are bonding, primary or secondary. Primary. So energy range for primary bond. Do you have idea any regarding this?
C, I think.
C. Okay. So option C is correct. So this is the range. Ionic bond has greater than 100 kilojoule per mole and covalent 50 to 350, metallic 20 to 350, or secondary less than 10 kilojoule per mole. Next question is which of the following is are belonging to the secondary bonding type? According to the energy, you can say or ionic is primary, obviously, and please answer the question. This will not be the secondary.
So hydrogen and van der Waals.
And covalent, in previous question you can see covalent bond, ionic bond, and secondary bond has less energy. So covalent ionic and metallic bond considered primary. So secondary will be hydrogen and van der Waals. So answer is hydrogen and van der Waals only. Okay, let's move to so this is the explanation. Professor has already discussed in class. Secondary bond will be and arise between the charged dipole. You know the dipole when electron positive and negative charge are displaced slightly, then form a dipole. This is called dipole, and this is the arise between the interaction between the charged dipoles. So this is the second bond in S2 or hydrogen bond. Okay, let's move further. The bonding types domain in the polymer material. Polymer material, this type of bonding have should not be had ionic or metallic. So left is covalent or van der Waals. This is also class of second materials. Okay, so this is the weak bonding material. Example is polyethylene chain covalent like C2H4, polymers HCl. Next question is which of the following is are to the polymer material? Polymer materials they have a linear stress strain curve. They have very high molecular mass They have high strength to weight ratio and they have low corrosion resistance. Answer. What will be the answer?
I think B, ANC.
They have very high molecular mass because they have long chain carbon chain. Like so, should be the high molecular mass and they have high strength to weight ratio. Which of the following can be contributed to increase the bond energy of the ionic bond? Can be contributed to increase the bond energy of the ionic bond? Ionic bond option A, large separation between the ion, then the equilibrium separation, large difference in the electronegativity of cation and anion, increase in the size of the ion, increase in the charge of the ions. So, what will be the answer? Answer is large difference in the ionic bond due to the high electronegativity bonds cation or atom anion and increase in the charge on the ions also. If the charge is higher than increase in the bond energy. So ionic bond two elements have large difference in the electronegativity and charge also contribute to the bonding energy. So next is which of the following correct increasing bond ionicity of the here is the side where you can find the about the electronegativity bond related so many things are available on this if you want. Let's see the video electronegativity regarding. Sorry, play on the laptop. Stop here. So, are you able to see my slides?
Sir.
So let's see. Here is the site you can find more about the bonding, electronegativity, non-polar covalent bond, ionization energy, electronegativity, periodic table. So,
Previous chapter, we were discussing periodic trends.
It's actually one more periodic trend that we need to discuss, and we tend to put it into the chapter involved in bonding because the periodic trend is an important aspect in bonding. The periodic trend is called electronegativity, and it's a measure of an atom's ability to compete for electrons with other atoms to which it's bonded. And we're going to see in this chapter that electronegativity is a very important property in terms of bonding. So the electronegativity depends on the ability of an atom to attract electrons. So this is going to be directly related to electron affinity, one of the periodic trends that we have previously discussed. And it's also related to the ability of an atom to hold on to electrons, which is going to be related to ionization energy, another periodic trend that we have discussed. The periodic trend of electronegativity follows the same trend as ionization energy and electron affinity, in that it increases as we travel to the right and go up on the periodic table. There's one very important exception to this trend, and that's noble gases, and noble gases have relatively low electronegativity. So noble gases do not really want to pull electrons onto themselves. So when we look at the periodic table, electronegativity increases as we go up and to the right. But remember, this trend falls apart when we get to the noble gases. What I like to remember is the most electronegative element in the periodic table is fluorine.
so here you can find the video and regarding question answer also, and more visualization of the bonding, ionic bonding, polar covalent bonding with proper explanation. Okay, so please visit this site and find the answers and clear your doubts. So answer of this question is lithium fluoride is higher than lithium chloride, zinc oxide, silicon carbide. Next question. Following attributes is are necessary for unit cell of primitive lattice. So what will be the answer regarding unit cell of primitive lattice? Hello,
C is one of the answers.
it is the smallest repeatable units, or C is answer. Shape of the primitive unit cell is not fixed. Okay, primitive unit cell has larger volume than the non-primitive. It is smallest repeatable unit and it is more than one lattice points. So answer is shape of the primitive unit is not fixed. This is also right, and it is the smallest repeatable unit. C is, but also A is also. Shape is also not fixed. Primitive unit cell, which cell has one atom in a cover by the smallest repeatable unit called primitive unit cell. We will discuss these things in later in much more detail. So smallest repeatable unit, and alpha beta is the length parameter, and angle is also called unit parameters, unit shape parameters. Shape may be square, rectangle, So sap is also not fixed. With an increasing in bond length, the bond energy of the material. If bond length increases, then what will be the bond energy? Increase or decrease, may either increase or decrease or does not change. Hello.
It decreases probably.
So if the bond length increase, then bond energy material will be decreased. So you can find there also regarding bond length, bond energy and bond length, relation between bond order and bond energy, single bond, double bond as a value, and also video lectures. The last and sorry, uh, there is a video also. Let's see.
In previous chapters, we've discussed how bond formation actually has stabilizing effects. So it makes sense that in order to break a bond, it will require energy. The amount of energy is called bond dissociation energy, and it's represented by the letter D. And this is the energy required to break a mole of covalent bonds in gaseous species. There are a couple of trends in bond strength that we can discuss. The first says that bond strength tends to increase with an increasing difference of electronegativity in the atoms involved in the bond. Here we're going to be able to closely see this by showing a series of bonds where one of the atoms is the same and the other atom is changing. This means that the electronegativity of hydrogen is being held constant, while the electronegativity of the corresponding halogen is being changed. And remember, the periodic trend for electronegativity says that it increases as we go up. So fluorine is more electronegative than chlorine, than bromine, than iodine. And correspondingly, the largest difference in electronegativity between hydrogen and the halogen is going to occur with HF, and the lowest difference is going to occur with HI. And you can see that there is a corresponding increase in the bond dissociation energy. HF, which has the largest difference in electronegativity of the two atoms involved in the bond, has the highest dissociation energy. And HI, the one with the smallest difference of electronegativity of the atoms involved in the bond, has the lowest dissociation energy. Another trend says that bond strength increases with the bond order for bonds between the same two atoms. So here we have two carbons that are bonded together, and we're increasing the number of bonds between them, and that's what we mean by bond order. A single bond has a bond order of 1, double bond has a bond order of 2, and a triple bond has a bond order of 3. As the number of bonds increases, there is a corresponding increase in the bond dissociation energy. So the CC bond has the smallest bond dissociation energy, while the carbon-carbon triple bond has the largest bond dissociation energy. We can see the same trend in a carbon-oxygen bond. Here, a carbon-oxygen single bond is weaker or has a lower bond dissociation energy than a carbon-oxygen double bond.
So 1 minute. You should visit this site and find the more about the bond energy, bond length. Please visit this site. Okay, let's move further. At the equilibrium separation between the atom, the condition satisfies each other. At the equilibrium separation between the atoms, bond energy is minimum, potential energy is minimum, force is attractive, net force is zero.
Potential energy is minimum and net force is 0.
So answer is P and T. Please remember this curve. This curve is also asked in any interview, PhD interview or many more places. So upward force is reverse downward force. Downward curve Fa is air represented by attraction force and R represented by repulsive force, and 0 is force where is 0, and corresponding to the potential energy curve we can see R naught where is the potential energy is minimum and force is 0. You can see in the graph. Okay, it is related to the interatomic forces or distance between two atoms. And can you tell me where is the system will be the more stable? Any system can be more stable where
Equilibrium state.
when equilibrium state. What is the equilibrium state? Where is force is minimum, maximum, or kinetic energy, potential energy? Please, intern,
Where the energy is minimum.
please type of energy.
Potential energy.
So, so system has not. You can see potential or total energy of the system is minimum. Then system is more stable. So red curve, please look the red curve. Not potential
Sir, I have a
energy. Yes.
sir, I have a doubt regarding this force curve.
Yeah.
Yes, sir. So I wanted to ask that when the two isolated atoms are brought closer to each other,
Yes.
the attractive forces are generating. Then at the equilibrium position, there is no net force. Then after that, when they are much closer to each other, repulsive forces are generating.
Yes.
I wanted to ask that how the repulsive force curve and the attractive force curve are starting from the same position, from the right, on the force curve versus interatomic distance curve.
So this is above side is a repulsive force and downward is attractive force. So you want to the curve should become
So I think, sir, the attractive curve should be where it is, and the repulsive curve should be a bit on the left, I think, maybe.
let me think. Y is left. Y is left. Y should be the little bit left.
Sir, because when the two isolated atoms are brought closer to each other, the attractive forces start to appear, and it should increase, and hence the attractive force curve should appear. And after the mean position is reached, um, and further distance is closed between these two isolated atoms, then the repulsive forces should start generating. So I think it should appear on the left, the repulsive forces curve.
Okay.
Mhm. We
Your
are starting at the exactly same position, up and below the axis.
okay. So this is the in MSc we have. Let me find the force equation. we will let discuss. Later we will discuss these things again. Okay, in next class.
Okay, sir.
The next question: which of the following are true for the point lattice? Which of the following is true? Options: it is a regular and periodic arrangement of the points in space, or each point in a lattice has identical surrounding. It is random distribution of points in space. Volume of the primitive lattice is larger than the non-primitive. So question, what is the question? Which of the following is are true for a point lattice? Point lattice.
I think A is correct and
Hmm.
B is correct, maybe.
So it is a regular and periodic arrangement of points in space, and each point in the lattice will have identical surrounding should be. So sir already told this periodicity and identical neighborhood. Okay. So which of the next question? Pick up pick out the correct statement in the following regarding the primitive unit cells. A primitive unit cells doesn't necessarily have to contain one formula unit for a molecule. B option: a crystalline structure has lower bond energy than that amorphous structure. Choice of the shape of a unit cell in a point lattice is always unique. Higher coefficient of a thermal expansion of a material is generally a manifestation of lower bond energy. Composite material have larger specific strength compared to the metals, ceramics, and polymers. When we move down group in the periodic table, the electronegativity increases. Correct statement, please.
So composite one is correct
And
and A, primitive cell.
A, D, and E. Please look the higher coefficient of thermal expansion of material is generally lower bond energy related, and composite material have higher specific strength compared to metal, ceramic, or polymer. Sir already discussed these things in class. Yes or no?
Yes.
Okay. Next question. Microstructure feature of the material that can be measured in the scanning electron microscope. These are: in micro scanning electron microscope, grain, Vacancy, interstitial, grain boundaries, the star feature can be seen. Do you have idea about the electron microscope? Optical microscope, what is the relation of optical? your eyes and electron microscope. Answer is grain and grain boundaries. Sir, discussing class. Next, we can see at macro level. Macro level optical scanning through electron microscope. Macro level 10, we can see nano level, atomic level. So when accelerated electrons hit the ion trail and generate secondary electrons, give the information about the imaging and imaging will the grain and grain boundary information contains. Next is which one of the following cell has the lowest symmetry? Monoclinic, hexagonal, triclinic, tetragonal.
Triclinic.
Okay, so answer is triclinic. These are the seven primitives crystal systems: triclinic, monoclinic, homoloidal, hexagonal, orthorhombic, tetragonal, or cubic. So, do you know the primitive unit cells parameters? ABC related to the length of the unit cell, alpha, beta, gamma related to the angle. And please remember what is the alpha, beta, gamma for triclinic, monoclinic, homoloidal, seven systems. For all seven systems, please remember, and alpha, beta also, alpha, beta, gamma. Do you know? Do you have studied in your previous class these things? Please find the answer alpha, beta, gamma for to be tetragonal, orthorhombic, hexagonal, seven systems. You have 5 minutes. Please tell me the relation between the ABC and alpha, beta, gamma. I will be come back in 5 minutes. Please find the answer. Okay, you have 5 minutes. Question is Hello. So
Yes, sir.
this is the answer. Please, please remember. Sir will ask in class, maybe in next class will be teach. So simple cubic has A B C equal A. Length are equals in simple cubic. This is the cubic unit cell. Body center also is cubic. Face center is also cubic. What is body center? What is face center? Do you know? Shailesh?
Yes, yes.
So what is difference between simple cubic or body center or face center?
What is the difference between the arrangement? Actually,
Yes,
in simple cubic, all the atoms are at the corner, but in body center, there is one in
extra,
the
extra.
center of extra atom. Number of atoms increases to 2, and in FCC, number of atoms are total 4 on the each face having one and at the corners.
So as corner atoms, what will be the sharing in unit set?
But
One
1
atom,
by 8.
1/8. So 1/8 and 8 corners. So 1 and for simple cubic. In body center, we can see there is a one atom on body which is totally occupied in unit cell. So this is 1 and 1/8 8. So will be the two answer number of total atoms. And what will be the sharing of the face center?
Half.
So how many faces are there?
6 faces, so 3 atoms.
Three atoms and one atom from corners. So here will be the four. And this is the same cubic. Cubic has length are equals and alpha beta gamma also 90,
Equal and 90.
90 equal and 90. So regarding this simple cubic, and what about the triclinic? What is the relation between length and alpha beta gamma?
Or which one?
Triclinic, monoclinic. First, let's discuss triclinic.
In triclinic, all the lengths are not equal.
Lengths are not equal, and alpha beta gamma.
They are also not equal.
What will be the value of alpha beta? Gamma it is not equal to 90. We can see
I
alpha
think in
beta.
triclinic angles are alpha, beta, and gamma are also not equal, and
Yes,
not
yes.
equal to 90 degree also.
So in monoclinic, we can see
Monoclinic,
has a relation between the beta and gamma 90 and alpha not equal to 90. But the length,
length are not equal. A is not equal to B is equal to, not equal to C.
so and orthorhombic. This is the simple. This is the center. Here is a simple base center, face center, and body center, which is also orthorhombic. So how many systems these? 8, 1, 2, 3, 4, 5, 6, 7, 8, 9,
14.
10, 11, 12, 13, 14. One is hexagonal. So please remember the relation between the length and angles. In XRD, 2D sin theta equal to n lambda, and where D is related to the alpha beta gamma and also ABC. So this is all about. Let me discuss first one more question. question. Isometric or cubic determinant. Hello, Anmol, are you there?
Yes, sir.
So your answer regarding the attraction and repulsive force. So maybe in magnitude is different, but starting from both are same. Let's discuss. We can discuss right now because we have a time. Are you able to see my slides? Let me. So this is the repulsive force, and below is attractive force, and this is the force response both. Below.
Yes, sir.
So magnitude is different. You can see value is different in y-axis, positive or negative. So combination of these forces, this is the red line, force curve response. Okay.
Yes, sir. Yes, sir. Got it.
Okay. Thank you.
Yes,
So
sir.
so next class is based on the unit cells, and please clear the unit cells. What is primitive unit cells, how many different type. One question in net or get may be asked or asked many times regarding the unit cells, primitive unit cells. What is primitive unit cells? How many atoms or lattice points should be there in primitive unit cells? Anyone has the idea?
Primitive
Your
unit cell.
yes,
Hello.
yes, yes,
Primitive unit cell have is basic. It is the basic one, like simple cubic, in which no other lattice points are in between. Actually,
should be
it is
1 point. No, should be 1 point.
uh, yeah, but
Total sum.
uh,
Yes,
in between there should be no points. Like it is the crystal structure that is with lattice points. Without there should be no lattice points within this primitive unit cell.
yes, yes.
It is the lowest possible cell.
Mm, and let me more discuss about primitive unit cells. Can we discuss if you have time?
Yes, yes. Good talk.
Okay. So let me see. Let's discuss. Are you able to see my slides?
Yes.
So left side is unit cell, right side is the primitive unit cell. What is the difference between primitive and unit lattice cell? Let's discuss. First, can have any number of lattice points, more than one choice for poles. Effectively should be the one lattice points. Primitive unit cell has also a unit cell, but vice versa is not true. Standard choice for the primitive unit cells with lattice points only at the corners. Standard choice. If you ask, please choose the primitive unit cell. So your choice should be first is lattice points should be at corners, at only corners, where you can see in the picture, and with lattice points at the center. And another type is we will discuss in later, reciprocal proving zones. So this is the unit cells. Let me tell you unit cell or primitive unit cell. First, second, there is the numbering 1, 2, 3, 4, 5, 6. Are you able to see? So please tell which is primitive cells or which is non-primitive unit cells. Here is also first is, let's check one by one. First, this is unit cell, also primitive unit cell. Why is primitive unit cell?
All
Check
the items are
one,
corners.
and sharing will be one.
One by
Total is one, and second is also, third
primitive.
is, why is third is not? Because extra atom
Yes.
are there. Clear? So third is should not. Okay, and more. Are you understand?
Yes, sir. Yes.
And fourth, please tell answer.
Not primitive.
And fifth and sixth. Sixth is
Six is
also,
primitive.
six is also only four atoms. Shape may be different. Why is not five? Four.
So I think we cannot generate the whole lattice using fifth.
Yes. So we cannot repeat. If we repeat the fifth in whole space, then we will not cover all the points. This may be the answer or may be different. And answer is also here. All the lattice points should be related by the translation vector. This is the translation vector. T equal to L. L M N is the length and ABC is the vector. Okay, so unit cell bulk has 3D unit cell, 2D has planar, or 1D has linear unit cells. If material is bulk, so unit cell will be 3D. If material has 2D, then unit cell, what will be the unit cell? Planar. Clear? And 1D should be unit cell linear. Like, question, here is the question. Are you able to see? So first question, what is the first question? Is the smallest area unit cell having one lattice point? Second question, is this is a primitive unit cell or not? The third question, are all of these primitive unit cells? Please find the answer of these questions. You may take a screenshot. I will ask in the next class. Please take a screenshot. Please find the answer in next class. I will ask. This is- Do you have any book regarding this?
Yeah.
Semiconductor book that he has. Let find. Yes. So